Yo, Plum Life. I thought I'd do a little bit of a talk on the three-port valve. Maybe you're a heating engineer, maybe you're a customer, maybe you're a heating engineer that's out there doing it every day, but never actually taking the time to just look intricately inside the three-port zone valve. Maybe you're new to it, maybe you're a customer, maybe this is your house and you're wondering if your heating's playing up. But it's a whistle-stop tour anyway, so let me get cracking with it. So this is a typical three-port mid-position zone valve. So they used to just prioritise to hot water. That would be a diverter valve, but this is a mid-position, which means it can feed both hot water and central heating at the same time. There's three ports on it, three-port valve. Typically you have your A port, which goes to central heating, your B port, which goes to water, and this is your C port, which is the flow from the boiler. So the flow comes in here and it can either go to heat and hot water, and inside here there's like a ball or a paddle or something along those lines, which the motorized head can move to shut off either port, or it can sit in the mid position to allow flow to both. Now obviously there's only a certain amount of space and flow you'll get through here, and which means there's only a certain amount of BTUs that you can pass through here. So when you're designing heating systems, you need to make sure that the required kilowatts that you need at wherever it's going gets there. So three-port valves are typically they're on small to medium systems in the domestic sector, and essentially if that flow is no longer big enough to provide the kilowatts that you need, you then typically move on to zoned systems where you have two-port valves which come in various different sizes, and then an up and up from there. But this suits a lot of domestic situations. So what you'll see at the back there is a shaft, and that shaft runs into the actuator head to control the paddle or ball or flap or whatever it may be that's deciding what's happening in terms of flow, hydraulic flow in your central heating system. So this one here, okay, if we just remove the actuator head cover, inside you will see a synchron motor. Now this it's an inexpensive motor, normally about, I don't know, £8 or £9. But it's when it's connected on two wires, and these two wires, when it's energized with 240 volts, these have got quite a lot of torque, these motors, because you've got to imagine this might actually be trying to push a valve closed or a port closed, sorry, that's got quite a lot of flow velocity going through it, so it needs a lot of torque. But it's a synchron motor, so basically it energizes, it moves in one direction, and when the mechanism meets a stop, for instance, the motor stops turning, but the actual motor still stays energized. Okay, it passes about 5 watts through here. It doesn't burn it out or damage it or anything like that. It's actually designed to operate like that. That's when the motor is energized. So if we just remove this motor, you'll see that it's got a little gear on the end. Yeah. And that's what it does, and typically they're connected. This one's connected on spade connectors, so if I just remove them, there we go, look, that's easy, isn't it? Easy peasy. So that motor is what powers the valve, but if you just take this base cover off, and here, so this is showing the valve in a resting state, and what you'll see is it's sprung loaded. Yeah. And typically, when the motors break down and stuff like that, people call in and say they haven't got any central heating. They've got hot water but no heating, and that's because it rests in the hot water only state. So if I now blow through the C port, it should come out of the B port, like so. So if I cover the B port, Nothing. Okay, so that's its rested state, and we'll come to how this actually works in a minute, in a little bit more detail on your system. But you see it's sprung loaded, yeah, and there's a little indicator here that moves to show where on the valve, whether it's in mid position, hot water or heating. So it moves this mechanism here that's geared, and it hits a micro switch. And when it hits that switch, it then knows where its position is. But you'll also see this. You see this little plastic thing here. This is the manual override. So if your valve was to break, you'd move this over to the central heating position or the mid position, and then you see it pushes in, and it locks. So that means you can lock it there, and you can have your hot water on, and it will be heating your heating system at the same time. It would do both demands, and it's just a way of overriding things to get heating back on. You might be talking to someone over the phone how to get the heating back on because you can't make it out to them. This might be your house and you haven't got any central heating, and you're looking into what's going on in your system. But to on this particular valve, if you just pull that back out, or the next time the valve's energized, it should reset into its normal rested state. There's all sorts of things that can go wrong other than the motor. You can have the gears mesh, the actual gears shred it, and they don't sort of meet properly anymore. The micro switch down the bottom, you can get tacky contacts that either don't make or they're not unmaking. And various other things. But what I wanted to really move on to is the wiring and how this baby works. Okay, so anyone familiar with the Y-plan system, as we call it, it's tried and tested, and there's loads and loads and loads of them out there. It's heating engineers and heating engineers will be very, very familiar with how this works. But sometimes we work so fast that we've got so much on that we don't take the time to really go into some of the intricate detail, and maybe that's what this video is about, really. So anyway, if we take these 5 wires, you notice that you've got your earth, which obviously earths the body of the valve to the earthing system, and you've got your neutral, which obviously completes the circuit. And goes back to the neutrals on the wiring center. But it's these 3 wires I really wanted to concentrate on. Right, so if you go to a boiler and it's not receiving a demand on the switch live to the boiler, you go back to the wiring center. Really, after checking you've got power to the wiring center, the first place you're going to look is the orange wire. It's nice and bright and bam in your face, and it'll be the first place you look to. Have you got voltage there? If not, why not? And you work your way back, is how I do it anyway. Maybe you do it differently. So the signal from the orange ultimately is the one that turns the boiler on and starts the boiler firing in a way, and I'll explain that more in a second. Now the white wire, if your program is on and you've got demand and you turn your room thermostat up, it's the white wire that receives signal from the room thermostat. And what this will do is it will move the valve into the mid position state if there's a hot water demand at the time. And if there's no hot water demand, it will move it entirely over to the central heating side, so it's fully motorized over, and I'll tell you how that happens in a minute. Now, if there is a hot water demand, your cylinder stat will be passing. It doesn't actually go through the valve because the valve is in its rested state. The hot water port is open. There's no need for the valve to do anything. So what happens is the hot water on from the cylinder stat goes directly to terminal 9, I think it is, where the orange meets up, and the one that then sends back to the boiler. So the power is going through the cylinder stat straight to the boiler to say, yes please, let's have it. Now when the cylinder stat is satisfied, and this is why we have a hot water off terminal, which we don't have on the heating typically, Now the hot water off terminal is important because when in that situation, it then sends power to the this grey wire here, and it's that grey wire that provides the energy that moves the valve from the mid position fully over to central heating only. So if you've got a valve that's stuck in mid position, maybe it's not receiving the signal back from the cylinder off, these zone valve heads, the actuators come off. There's a lot I could say about the various different valves. You've got Honeywell, you've got Drayton, and you've got loads of different other ones. Some of them are compatible, some of them you can swap straight over, some of them you can't, all sorts of different stuff. But that is really just a whistle stop tour on the 3-port mid position zone valve. Okay, happy plumbing.